Start the record.
Hi. I'm pleased that Steve Miller is joining us tonight. Steve is a 21-year member of the Western Interior Paleontology Society, otherwise known as WIPS. Steve has studied the Western Interior Seaway deposits that outcrop throughout the region. His efforts have focused on helping WIPS members learn about the dynamics of the Western Interior Seaway, creating educational experiences that offered more than just mere collection of fossils. During some of the visits to the Comanche National Grassland, he oversaw the collection and eventual donation of hundreds of significant fossils to various museums, from Denver to Kansas City, Colorado to Fort Hays, Kansas. Steve's retired from a career in high technology in 2021 and has been working on a project to study and outline the biodiversity expressed in the U.S. Geological Survey Denver Mesozoic collection of Cretaceous fossils. Steve lives in Colorado Springs, Colorado, and welcome, Steve.
Thank you, Catherine. Okay, let me share my screen here. Go ahead and share screen one and bring up. Here we go. All right, guys, do you see the presentation screen or the speaker's screen?
We see the speaker's screen.
Okay, hold on.
That always confuses me, how to get that
Yeah,
right.
to be honest, I don't care to use it, but I've got two screens and I don't
Sure.
want. That's okay too. Here we go. Apologize for this.
No worries.
You know what? I know how to do this. Share screen two. There we go. All right.
There we go.
Okay. Go back to the beginning. Okay, tonight I'm going to share the Western Interior Seaway. I'm going to talk here a little bit about a project that I have started and for visually impaired folks. And it's based on sharing knowledge and understanding of Western Interior Seaway and life, as well as some other aspects. I'll introduce you to the Comanche National Grassland, show you where it is, give you a little bit of background on why it was important, and then I'll introduce the video and we'll watch the video, which really kind of highlights what WIPS has been doing down at the Comanche National Grassland for 20 years. So I'm at a point where I have been fortunate enough to take a crazy idea, which is to develop a tactile experience for visually impaired people to communicate and convey the whole concept of the Western Interior Seaway. And I want to do this. I use representations and artifacts of the Western Interior Seaway to lead the audience into deep time and share some of the wonders and changes in the earth and creatures that lived at the time. Now, this is kind of an interesting task when you think about people who are visually impaired because their whole ability to intake information aside from hearing is tactilely. So, um, one of the things I'm looking at is paleogeography, and this is just a sample representation from an open source paleogeography project, and it shows three stages of the Western Interior Seaway on the right side at 110 million years. The Cenomanian, which is approximately the high stand of the Western Interior Seaway, and then the Maastrichtian, which is after the final regression of the Seaway at 70 million years old. So the challenge is, how do we convey this information to people who have to deal with it tactily using their fingertips? And I got to thinking, it'd be really nice if we can do a slice of the earth bearing the North American continent, since we're talking about the Western Interior Seaway. What would that look like? So I went out and I found just a generic globe of the United States. I didn't care for the particular rendition of the Earth with the beveled edges and the highly raised sides, but this was a proof of concept. And now what I wanted to know was, could I get enough curvature to give a sense of the continent on the surface of the Earth? Because again, I want to convey this in a way that people can touch it. And I think if you can demonstrate the immensity of continental and tectonic motion, the Western Interior Seaway. If we can do that with a larger model, that would be good. So I set about the business of enlarging it. So I took the model, I sliced it twice, actually three times, because I sliced each half again, expanded it 200%. To scale up, and the features aligned well. The pieces were printed at different times, so you can see there's the northern hemisphere, or the northern part of this slice. The larger map allows for inclusion of icons and guides on the surface. When you're building paleogeographic maps and media for communicating to visually impaired people, it's always a good idea, so I'm told with all of the research, to include guides to help visually impaired people interpret what it is they're touching on the map. So the larger map is definitely an advantage. So here you can see them side by side. The scale up was a success. I can print out the map. It takes quite a bit of filament, but it's worth it because I get a nice map that's about 18 inches in diameter with a good chunk of the ellipsoid surface of the Earth. So instead of just giving people a two-dimensional flat representation of the Earth, and then if necessary having to talk about projections, etc., I said, no, we got 3D technology. Let's use it. So we're going to do the Earth in 3D. Okay, cool. Ammonites were cool. What else goes into a tactile experience? Actual ammonites. So models of real fossils. This is a model. This is publicly available from the Smithsonian Institute. You can download it. You can print it yourself. And it's pretty neat. That's Exitaloceras genii up there. There are two whorls, a complete one and a partial on the other side, and about a half dozen Hoploscaphites all knotted up in this thing. And you can see two of them there. And a little bit of the third one. Third one's creeping out down here. And here's one, of course. And then there's another very large one. So in addition to real models, I will also be sculpting ideal representations of models. This is a Mammites nodosoides. It's an ammonite of the Bridge Creek member of the Greenhorn Limestone Formation. So I was able to sculpt this in clay, and then was able to render it as a 3D object. Another one that came to me, again, trying to share some of the different aspects and interesting things that come from the Western Interior Seaway. We'll be using real fossils as well as sculpt fossils, and using photogrammetry. Shelley Llewellyn, who I understand, and Shelley's on tonight, presented in October, told you about Shelley. She's an absolute whiz, a great instructor. By doing my own photogrammetry and my own enlargement, or my own processing, then I can take these features. Here's the run for the photogrammetry. So the segment of the baculate bears great sutures, which is something I want to convey as part of this experience when we're talking about ammonites millions of years ago. So I set this specimen up, and I made 3 passes with the camera, and I'm sure Shelley talked to you about that. You arrange the object, you put it on a turntable, spin it every 10 degrees, take a picture, and then after you do a round, reorient the object, spin it again. And you can see here in the 3D model that I'm developing some pretty nice sutures. So again, thinking about the end result is, how is this thing going to be perceived in terms of touch? So we put it in the 3D printer, and sure enough, those sutures actually turn out pretty good. So this is in an effort, this is part of the scaling up process. So the final will be printed out about, here I'm printing it about twice the normal size. The final will be probably twice again as large as this. The suture marks will be available and they'll be traceable with a fingertip. So, and that's something you don't normally get to see, but this fossil specimen I picked up at our annual auction was weathered just beautifully to highlight these features. I do have ideas for vertebrate material, but I'm going to just keep those to myself for now. Just let you know I do have ideas. But if you think about what you just saw, you'll probably figure out where I'm going. Also in 3D printing, I came across a video the other day of a landslide on the California coast. Some guy shot the video with his drone. Well, I have a drone too, and it's a lot of fun to fly around. So he shot this drone video of this landslide. And something I didn't realize, but one of the tools that I have allows me to pull frames out of the video at a particular rate. So I can actually take a video, extract frames, run them through the Metashape software, and produce a 3D model. So I'm thinking about including landforms in this tactile experience where there are certain kinds of landforms that are very easy to describe and have very large surfaces like this particular hogback, and that's a Dakota sandstone on the top. May be able to render a portion of this and convey to people that who can't see that these outcrops appear. They're very large, but they're also very distinctive. And once you see one in one part of the state, you can go compare it with others in other parts of the state. So landforms could be interesting. This is a valley in eastern Pueblo County, and this is a shame. This was BLM land. It was recently sold to the state of Colorado, but those are TP Buttes. And this is another opportunity, I think, for doing drone video-based photogrammetry for processing features so that we can express the TP Buttes and explain what they were, why they existed, and what they mean to us today. So anyway, these are some of the thoughts that I have percolating, and I am moving ahead full speed right into the beginning of next year to start producing these items and start testing. I'll be be making contact with people at the Colorado Springs School for the Deaf and Blind to see if I can scare up some recruits to help with this project. Is another landform. This is the Bridge Creek member of the Greenhorn Formation. And again, if this can be printed out in 3D so that it can be touched, it helps explain a very interesting period in the Earth's development. Those alternating beds were produced by changes in climate that were induced by wobble in Earth's rotation in orbit about the sun. So there's just some really great ways to help express to visually impaired people concepts that will help them sort of expand their understanding and develop some framework. So when I'm putting together the actual content that explains a lot of this, I'm going to have to be very aware of how visually impaired people process this tactile information. So very exciting project coming up doing all of this. That last photo was taken in an outcrop in the Comanche National Grassland. And this is kind of a very light figure, but the green, yellow-green area in there, sort of a patchwork, is the Comanche National Grassland. It was purchased by the U.S. Department of Agriculture right after the Dust Bowl years when farmers were just throwing in the towel because it's not a very conducive place for farming. All of the ranching that goes on there now today is cattle ranching. But it is a sizable area. All of those squares, if you're familiar with the PLSS, those are all one mile squares on there. So there's quite a bit of area. The town of La Junta is at the top. It's on the Arkansas River. It's on US 50, east of Pueblo and the Front Range by about 60 miles. There's a little bit of pink showing down there at the bottom. That's the Pinyon Canyon Maneuver Area. It's a training area for Fort Carson, which is in Colorado Springs. So you see this sort of irregular shape. But if we go to Google Earth and we take a look, and then we get some other resources, and we develop an outline of the exposure of Cretaceous rocks, we can see there's a pretty sizable portion between those two yellow lines. Those are all marine Cretaceous rocks. Those are all the Western Interior Seaway at the Comanche National Grassland. And that is where, for 20 years, we've been reading, researching, going out in the field and poking around, not only looking for fossils, but also looking for other aspects of paleontology. And all of these things I'll share with you in the video. But when you overlay the Comanche National Grassland, you can see that almost all of it, except for one little portion right up here, all of this is Cretaceous. And this line that runs from the upper right corner here near the eastern border of Otero County, diagonally down to the south about the center, you can see that that bright white margin. That is very simply the uppermost Carlisle and lowermost Fort Hayes, and it is hundreds, literally hundreds of miles of outcrop that can be walked down there. And in 20 years, we may have walked all together maybe less than 10 miles of outcrop. And I'll make a point about this again in the video. You'll see. Okay, so now I want to introduce to you the video. Earlier this year, I was contacted by JP at the Tate Museum, and he asked if I would do a presentation about what we've done at the Comanche National Grassland. The theme for this past year's conference was the Western Interior Seaway. And he asked if I could do this, and I accepted. And about the same time, I was given a diagnosis of stage 4 lymphoma. So I didn't know if I was going to be able to actually make the conference. So I asked JP Cavagelli if I could do a video. I had no idea if I would be dealing with side effects. I had no idea what my treatment schedule would be, but I really wanted to do this project. So he agreed and let me do this. And I worked on this right up to and through my first round of treatment. And it was a great project for me at that time, a great thing for me to be able to concentrate on something really sort of rewarding. My perspective as a field trip leader for WIPS was to try to make these trips useful and valuable as opportunities to learn something, more than just say, oh, well, if we go here, look for this fossil and you'll find a bunch of them. I wanted to make it so that we would actually have some sort of engaging activity if we could. I reported what we found to the Forest Service, and you'll see here that we actually found some really remarkable stuff when we set about learning, more than just set about going out and collecting fossils. So at this point, I'm going to stop the share. Catherine, if you want, and now you can go ahead and share from your machine. Oh, you're muted. Or
Okay, hold on one moment. See if I can remember how to do this correctly. Because we had to go through it. All right, is everybody ready? Can you hear it?
no, you didn't you got to hit the check
Oh,
box.
shoot. Sorry. And we did do that too. Hold on one second.
It's okay.
I'll go back to the beginning on it first. See, this is why we have other people doing it, not me.
I can do it
Yeah, it's okay. I got it now.
you got all right.
All right.
Hello, my name is Steve Miller. I'm a member of the Western Interior Paleontological Society. For the rest of this presentation, I'll refer to my organization as WIPS. WIPS is a charitable organization that supports paleontology, science, and education. WIPS organizational goals also include educating its members as well as the public. I live on the Colorado Front Range, and in 2005 I went to the Comanche National Grassland out of plain curiosity. This is one of the more remote, austere, and yet lovely regions of Colorado. I used to tell people, if anything has burrs, spurs, needles, fangs, or venom, it lives there. While I was there, I discovered an ammonite in a hard brown sandstone on the slope of a bluff. Immediately, I thought this would be a great place to share with my WIPS colleagues. That discovery on that visit indeed kicked off 20 years of education about the Western Interior Seaway. I love the dichotomy of the Comanche National Grassland. The present-day natural environment, the canyons, high plains with its grass, cactus, and pinyon, draped over terrain comprising formations of rocks, which started as mud and sand on the shore and floor of the Cretaceous Western Interior Seaway. Welcome to this presentation in which I share observations from 2 decades with the Cretaceous rocks and fossils of the Comanche National Grassland. For the next several minutes, we'll travel up the stratigraphic column that describes the rocks deposited there. I'll refer to this illustration by Bruce Schumacher of the U.S. Forest Service. We will start with the 110-million-year-old beaches of the Dakota Sandstone, which signal the beginning of the first major transgression and regression of the Western Interior Seaway. This cycle is known as the Greenhorn Cyclothem, and will end at the Smoky Hill Chalk, deposited in the following cycle known as the Niobrara Cyclothem. Throughout, we'll see fossils that were observed and collected.
I lost sound.
Both of your Zoom, there you go.
Yeah, I'm not sure what's going on, why it stopped. I don't understand why it stopped.
I've got it
Sure.
ready to go
Okay.
on my machine. We can try picking it up there.
All right. Sorry.
No. That's quite all right. Okay. I share. Okay. Let's close that.
Throughout, you'll see fossils that were observed and collected by WIPS members.
Looks
Some of
good.
the fossils we collected have become a part of WIPS educational collections, which are taken to various public events. Some of the more important fossils we collected have been reposited in various museums. I'll also provide overviews of some of the paleontological projects we developed and completed. The Dakota Sandstone Formation rings the Picket Wire Canyon, home to the continent's largest dinosaur track site. In the Comanche National Grassland, 3 distinct members of the Dakota Sandstone are present. They can be observed at the rim of the Picket Wire Canyon and in many of the adjacent tributary canyons, such as this one. This view clearly shows the 3 members of the Dakota Sandstone Formation: the Mesa Rica, the Pajarito, and the Romeroville. Of these 3, the Mesa Rica and Pajarito members are the most fossiliferous. We start with these 2 members because they provide abundant clues to understand the dynamic onshore and offshore paleo environments preserved. Preserved ripple forms can be found in situ and on displaced blocks of sandstone that litter the canyon slopes. We've found wave-generated ripples of varying sizes. Many interesting trace fossils have been found in the Dakota Sandstone on our trips, like this out-and-back behavior. Other trace fossils show modes of locomotion, like this pulsing action. Rhizocorallium, of course, and Undicna britannica. Likely crustacean traces, too. Note, the ripples here appear to be from a stream feeding an estuary. Our most interesting trace fossil was discovered in 2007. We thought at first it might have been produced by a crocodile, but we soon ruled that out. Then perhaps a turtle. Note the symmetrical smudge opposite the arc created by the claws. Finally, in 2014, we took Dr. Martin Lockley to study this trace. He made a drawing of the trace using clear plastic and a marker pen. Then he applied a coat of liquid latex to the surface of the rock, creating a mold. Dr. Lockley assessed this trace as that of a pterosaur, which makes me wonder about this trace fossil that was discovered in 2009. This particular ichnosfossil also gave rise to an innovation by WIPS member Tom Nolan. He discovered that collapsible floral foam, the kind used by podiatrists to create custom orthotics, could be used to replicate fossils and tracks without leaving a residue on the rock's surface. After pressing the foam, he poured plaster of Paris over the captured image to create a very detailed replica. In 2008, WIPS ventured into a tributary canyon of the Picket Wire to follow up on information that several dinosaur track fossils could be found there. WIPS members located and documented several tracks yielded by the Mesa Rica and Pajarito members. We published this compendium. Tracks included were Carraricnium, there were 2, Ornithischian dinosaur, Ornithopod, 2, Theropod, and Magnoavipes. Of course, we brought collapsible foam and produced replicas, which to this day we use to educate the public at events like National Fossil Day at Garden of the Gods. We also found many different fossils of plants in the Dakota Sandstone. Many of them came from the Pajarito member. Unfortunately, only one in this presentation has been identified, and that is this specimen of the genus Araucaria. Fossil trees, too. Now we get to the Romeroville member of the Dakota Sandstone Formation. This member has been largely left out of this discussion of the Dakota Sandstone because of all the great fossils we've seen in the Mesa Rica and Pajarito members. According to Spencer Lucas, the Romeroville represents rapid transgression of the Western Interior Seaway. However, fossil wood can be found on the very upper surface of the Romeroville member. Most likely, this bit of plant material floated out into the Western Interior Seaway, became waterlogged, and sank to the sandy seaway floor. This is where the Dakota Sandstone ends and the Granero Shale begins. Above the Dakota Sandstone lies the Granero Shale. This formation is described as upper and lower units separated by the Thatcher limestone. In USGS Professional Paper 645, Bill Cobbin and Glenn Scott formally described these two units based on their fossil-bearing characteristics: the lower barren unit and the upper fossiliferous unit. Indeed, the only fossils collected by the USGS from the lower barren unit are fish bones and scales from a single locality, D3971. We visited the Granero Shale at this monocline on our first trip to the Comanche National Grassland in 2006. In 2012, we visited this area where the contact between the Dakota Sandstone and the Granero Shale is much more obvious. At this same location, the Granero Shale is thick and accessible and has several harder beds. Unfortunately, no fossils. The Thatcher limestone crops out on the sides of a few canyons in the Comanche National Grassland. This rock unit, which divides the Graneros, is very hard, dense limestone. Its orange color makes it unmistakable. Some of the Thatcher limestone has converted to cone and cone. Only this one fragment of a likely acanthocerid ammonite has been found in the Graneros by whips. The upper fossiliferous unit crops out in a few broad surface exposures in the area. We have found no fossils in these exposures of the Granero Shale. However, we have found many concretions, with fossils of Ostrea beloidi on the prairie above the ravines and washed drainages where the Granero Shale occurs. Moving up the stratigraphic column, we'll look at the Greenhorn Limestone Formation, starting with the Lincoln Limestone member. Cobbin and Scott in USGS Professional Paper 645 separate the Granero Shale from the Greenhorn Limestone at the base of the X bentonite marker. On our first visit to explore the Graneros, we located the X bentonite marker bed. By digging a trench, we found it to be about 50 centimeters thick. A year later, and 30 miles away, we came across this exposure of the X bentonite marker bed. The Lincoln Limestone member sits atop the X bentonite marker and in the Comanche National Grassland appears in only a few places. While it is classified as a limestone, it is extremely soft and has eroded except for a few places where harder beds remain. Outcrops such as this are tempting, but WIPS members do not destroy this kind of outcrop to look for fossils. Eventually, as in a few years later, we find the harder beds of the Lincoln Limestone on the floor of an arroyo, where we saw this specimen of Inoceramus pictus. The Heartland Shale overlies the Lincoln Limestone. In 2012, we set out to measure the thickness of the Heartland Shale. This outcrop is unique in the Comanche National Grassland. It offers access to nearly the entire Heartland Shale member of the Greenhorn Limestone Formation, starting with the hard beds near the base. We found no fossils as we worked our way up. This view of the outcrop clearly shows the basal beds of the Bridge Creek member, which overlies the Heartland Shale. The Bridge Creek member of the Greenhorn Limestone Formation crops out at several locations across the Comanche National Grassland. In some areas, the Bridge Creek crops out in broad exposures on the surface. Because these areas support the growth of pinyon and juniper, they are easy to spot from some distance. These areas are also clearly visible in satellite imagery. Furthermore, these areas are close to the slopes of the Carlisle Formation. The Bridge Creek also crops out in a few arroyos around the Comanche National Grassland. One of our favorite arroyos presents a puzzle to members who are new to the area. Clearly, the Bridge Creek limestone is visible on the east side of the arroyo, but why not the west? The most likely answer is that the west side was washed away as the Ice Age glaciers melted. Alluvial fill comprising detritus from overlying marine beds has since been deposited and, of course, further eroded. A fault in the beds here creates about a 10 centimeter offset, with the lower beds slinking toward the Picket Wire Canyon. Every severe thunderstorm over the watershed for this arroyo turns up more material for examination and likely yields more fossils. This was a favorite stop for WIPS trips in many of the early years. It happened that 2014 was a very wet year in the region, fueling the growth of tumbleweeds, and this arroyo managed to catch much of that vegetation in 2015. It took a few years for the tumbleweeds to clear out. but perhaps the more impressive outcrops of the Bridge Creek limestone are found along Tempest Creek. This outcrop exposes the uppermost beds of the Bridge Creek limestone found in the Comanche National Grassland. The most complete outcrop of the Bridge Creek member is at a cut bank on Tempest Creek. One thing that makes this outcrop so special is the fact that the beds dip from south to north. Because of this dip, nearly the entire deposit of the Bridge Creek limestone is available for study. Over the years, WIPS members have collected many fossils from the Bridge Creek limestone. Some of the specimens have been identified as index fossils in the USGS Ammonite zonation published by Cobbin and others. Let's look at fossils collected in approximate biostratigraphic sequence. Uomphalanceras septum seriatum, Pseudocalicoceras dentinense, Scaponoceras gracile, Meroicoceras white-eye. This fossil was donated to the Royal Gorge Regional Museum. As part of their educational collection, this specimen nicely shows the concept of indolute fossils. Puebloides spiralis, Vascoceras greenhornoceras birchbii. This specimen was also donated to the Royal Gorge Regional Museum collection. Watanoceras coloradoense. This specimen was found in one of these beds, which have been uplifted at this thrust fault at another Tempest Creek cut bank. Alacreoceras annulatum, Mammites nodosoides wingi. This specimen appeared when I measured the Bridge Creek limestone at the Great Cut Bank. Mammites nodosoides, Tragodesmoceras bassi, Puebloides greenhornensis, Colignonoceras woolgeri. Moving up the stratigraphic column, we'll look at the Carlisle Formation, starting with the Fairport Chalk member. The Fairport Chalk member is the lowest member of the Carlisle Formation and overlies the Greenhorn limestone. Most of the Fairport Chalk accessible in the Comanche National Grassland can be found in arroyos cut into the prairie surfaces below the bluffs of the Upper Carlisle, with only a few exceptions. This cut bank outcrop of the Fairport Chalk was observed during a survey of the Blue Hill Shale conducted from 2020 through 2025. Donald Hatton documented the Fairport Chalk in the Kansas Geological Survey Bulletin 156. You can see his numbered marker beds, starting with a bentonite, number 1, just a few centimeters below a hard, chalky limestone bed, number 2. My first encounter with the Fairport Chalk was at this outcrop, where the surface alluvium was held in place by sparse vegetation, but clearly exposed these two easily recognizable beds. In the USGS Zonal Table, Open File Report 2006-1250, Cobbin and others list the species Colignonoceras woolgeri as the index fossil of the 20th zone from the bottom of the index fossil table. We ended our review of the Bridge Creek member of the Greenhorn limestone with the specimen Colignonoceras woolgeri. The fossil Colignonoceras woolgeri regulari is a specimen found in Hatton's number 2 bed of the Fairport Chalk member. I find it interesting that these two subspecies of Colignonoceras woolgeri have been lumped together for the zonation. This specimen is an unusual expression of the species Colignonoceras woolgeri regulari. It is an example of mort ichna, or death trace. Compare the imprint with the keel and ventrolateral nodes of this copy of a specimen from the USGS Denver Mesozoic collection. Another instance of mort ichna. This one from a more mature specimen and preserved as a cast created in the substrate above the impression. At the cut bank outcrop, we found Colignonoceras woolgeri regulari preserved in nodes of the chalky shale, such as this one. Also found at this cut bank was this fragment of the bivalve Inoceramus cuvieri. Other bits of indeterminate bivalves can also be seen in this class. The Blue Hill Shale member of the Carlisle Formation crops out across the region. The Blue Hill Shale member is one of the most widely accessible in all of the Western Interior Seaway deposits because it is relatively thick, and it slopes from the tops of the bluffs, resulting from hundreds of thousands, if not millions, of years of erosion. This member is well known for its production of warty septarian concretions. These concretions are found on the horizons near the upper middle of the member and range in size from a few centimeters to over 2 to 3 meters or more in diameter. Crystal fills in the septa, or openings created from pressure, appear in various forms. Rarely, concretions also formed around or within fossils, such as this specimen of Prionocyclus hyeti. Perhaps the most amazing find from WIP's 2 decades in the Comanche National Grassland was a fish-tooth conglomerate. Donald Hatton describes a fish-tooth conglomerate as evidence of wave activity. In 2015, this fish-tooth conglomerate was discovered near the top of the Blue Hill Shale. This discovery was made on the same horizon as the ammonite Prionocyclus hyeti that was just discussed. The mass was disaggregated with a 5% solution of acetic acid over the course of several weeks in 2018. I used small artist brushes to separate the bioclastic bits from sand and other clastic bits. The bioclastic bits were, at first, roughly sorted. The total mass yielded over 900 individual fossils. Here are some of the more interesting specimens that were recovered. This is Cretalomna appendiculata, and the bar is a 5 millimeter scale. This is a common shark tooth known for its 2 cusplets attached to the cusp. Scapanorhynchus rhaphiodon with a 10 millimeter scale bar. Coniosaurus crassidens with a 1 millimeter scale bar. This tooth is from a lizard that was a land-based creature that spent much of its time in the marine environment. Tychodus whippleyi with a 5 millimeter scale bar. There was also a very odd specimen of this shark in the batch of fossils recovered. This one tooth expresses the general shape of a tooth of Tychodus whippleyi, but it lacks all the surface detail normally associated with the species. Further research points to the most likely explanation for this by Kenshu Shimada. The tooth probably traveled through the digestive system of a larger marine predator. Squalocorax falcatus with a 5 millimeter scale bar. There were fossil teeth of more than one species of Squalocorax recovered. Here you can see the diversity in tooth shape and size. The scale lines are 1 millimeter apart. Cretotus crassidens with a 5 millimeter scale bar. Tychotrigon triangularis with a 5 millimeter scale bar. This was the only other species of durophagous fish whose teeth were recovered. Encotis cf. Encotis shumardii with a 5 millimeter scale bar. This is one of many specimens which comprise the palatine bone and tooth. Finrays with a 5 millimeter scale bar. These were the most puzzling fossils recovered. I contacted Kenshu Shimada with photos and questions as to what they might be. We ended up looking at Xiphactinus finrays as a guide. The shape of the fossil seems to match, but the size of Xiphactinus leaving such small bones would also have to be very small. So we cannot be sure of the species of fish, but if it was Xiphactinus, it would have been very small. All the fossils recovered from this conglomerate were taken to the Fort Hays University's Sternberg Museum of Natural History and entered into their collection in the fall of 2018. While I was researching fossils of the fish-tooth conglomerate, it became clear to me that the Fairport Chalk, Blue Hill Shale, and equivalent formations across the Western Interior Seaway express horizons where conditions were right for preserving fossils in significant assemblages. Some horizons in the Fairport Chalk contain hard shales bearing fossils with amazing preservation characteristics, as seen in these specimens of the USGS Denver Mesozoic collection. These were collected near Pueblo, Colorado, about 60 miles west of the Comanche National Grassland. Based on assemblages of fossils of ammonites and concretions in the Carlisle Formation, also observed in the USGS collection, I arranged a trip to investigate the horizon that produced them in South Dakota. We found the horizon and verified that assemblages of mollusks are abundant. Taken together, the research to identify fossils of the fish-tooth conglomerate and fossils observed in the USGS collection and in South Dakota shows that it's possible to find interesting fossils in the otherwise barren Blue Hill Shale. I sketched out an approximation of the position of the various horizons. From this, we started a systematic survey of the lower and middle Carlisle Formation. We focused on measuring the thickness of the Fairport Chalk and the Blue Hill Shale. The goal was to locate the thickest Blue Hill Shale. At those locations, we anticipated the possibility of finding conglomerates or assemblages left in storm-lag deposits. We went to 5 locations across the Tempest unit of the Comanche National Grassland. The locations were chosen because they are known to provide access to Hatton's Fairport Chalk marker bed within a kilometer of bluffs of the Upper Carlisle Formation, Blue Hill Shale, and Juana Lopez members. The marker bed 2 served as our datum for the survey, but is estimated at Site 3. Using a 5-meter grade rod and sight level, we measured the thickness of the lower Blue Hill Shale across the prairies where the shale is covered or otherwise eroded. Then on the slopes of the Blue Hill Shale, we used a staff and ab-knee level to measure the thickness up to the top of the Blue Hill Shale. The site with the thickest Blue Hill Shale we measured turned out to be the site where the fish-tooth conglomerate was collected. Future trips to the Comanche National Grassland might be considered for locations where we can reasonably anticipate the Blue Hill Shale approaches this thickness. And we might return to this site for a closer look at the top of the Blue Hill Shale. But from previous experience at this site, we know that the Blue Hill Shale is fairly well covered, making observations more difficult. The uppermost Blue Hill Shale in the Comanche National Grassland tops out in the Prionocyclus hyadite zone as described in the USGS Ammonite zonation published by Cobbin and others. This rare specimen was collected on a slope of the Blue Hill Shale just below the Juana Lopez member. The Juana Lopez member of the Carlisle Formation overlies the Blue Hill Shale in the Comanche National Grassland. McLean and others have described the Blue Hill Shale as the last deposit of the regression at the end of the Greenhorn cyclothem. When Whipps first started exploring the region, it became clear that the Codell Sandstone member of the Carlisle was nowhere to be found. This illustration from a field guide by McLean, Pinnell, Merriweather, and others of the Society of Economic Petroleum Mineralogists clearly shows that the Codell Sandstone is not present in the area south of the town of La Junta, Colorado, which is where the Comanche National Grassland is situated. This illustration also shows a lacuna in the deposition of any kind over most of eastern Wyoming and a significant portion of Colorado. This lacuna indicates one of 2 disconformities that define the upper and lower contacts of the Juana Lopez member of the Carlisle Formation in the area. This illustration from the same field guide by McLean and others shows that the Juana Lopez is a deposit isolated in time from the underlying Blue Hill Shale and overlying Fort Hays limestone of the Niobrara Formation. Also note that this illustration shows the Codell Sandstone, but we know from the previous illustration that the Codell Sandstone is not present in the Comanche National Grassland. The Juana Lopez member dominates the bluffs, which occur across the Comanche National Grassland. In some areas, because of the canyon rims standing after erosion, it is common to have access to 5 linear miles of Juana Lopez outcrop within a single square mile. In this image, the red line traces the bluffs topped with the Juana Lopez within a 1 square mile section of the public land survey system. Slumping and erosion at the bluff tops expose the Juana Lopez member, along with the uppermost Blue Hill Shale and the Fort Hays limestone, in some spectacular and dangerous outcrops. The Juana Lopez outcrops here represent a condensed section. This member of the Carlisle Formation is extremely fossiliferous, but despite being extremely fossiliferous, the molluscan biodiversity is severely limited because of the disconformities. The most abundant cephalopod fossils include Scaphites warreni and Prionocyclus wyomingensis. The most abundant bivalve is Lopha lugubris. Over the years, we encountered several large-ribbed ammonites we first identified as Prionocyclus macombi. But finding this one specimen helped us understand that robust ribs are not exclusive to Prionocyclus macombi. The opposite side of this specimen expresses what is clearly Prionocyclus wyomingensis. We received confirmation after an email exchange with Stephen Hook, who worked extensively with Bill Cobbin. He explained that in their adult stages, the species Prionocyclus wyomingensis and Prionocyclus macombi are virtually indistinguishable. For comparison, we put this Prionocyclus wyomingensis specimen aside a Prionocyclus macombi specimen belonging to the USGS Denver Mesozoic collection. You can see Prionocyclus macombi on the left and Prionocyclus wyomingensis on the right. WIPS members have found Mordicna impressions of Prionocyclus wyomingensis, such as this one, a mold, and this one, a cast. Over the years, we encountered some fossils that meet the WIPS definition of scientifically significant, and many vertebrate fossils as well in the Juana Lopez. All of these fossils were donated to the Denver Museum of Nature and Science. This arthropod was picked up on a slope below the outcrop. An Encodus palatine is shown next to a scale of inches. A collection over 144 Chondrichthyan and Osteichthyan fossils, including Tychodus whipplei, Cretalomna appendiculata, Encodus, an unidentified shark vertebra, and this exceptionally large, nearly 5 centimeter, Archaeolomna tooth. Other vertebrate fossils encountered include this likely Zophanctinus vertebra and bones of a plesiosaur discovered by a paleontology enthusiast from La Junta in 2013. WIPS spent several hours removing overburden nearby in the hopes of finding more bits of the plesiosaur. And, in our experience, we went to look for plesiosaur, and all we got was this lousy steinkern of Prionocyclus wyomingensis. We are now at the Niobrara Formation. Apparent bioturbation occurs at this contact where trace amounts of the Fort Hays deposits are intermixed with the uppermost Juana Lopez member. This can be seen in cross-section of the contact, and it can be seen in burrows of thalassinoides. In the Comanche National Grassland, the Fort Hays limestone is largely barren of fossils except for the odd inoceramid bivalve. However, coprolites in some places are extremely abundant. These coprolites appear in two forms, one in which the matter was deposited in a burrow owing to the tubular shape. The other form was likely deposited in the water column and fell to the floor of the seaway owing to the popcorn shape. The only ammonite we've discovered in 20 years is this specimen of Foresteria. Deposits of the Western Interior Seaway in the Comanche National Grassland top out at the Smoky Hill Chalk. Most of the chalk is covered except for a few outcrops such as this one. Other outcrops are on private property just outside the Comanche National Grassland boundary. The only fossils observed on a WIPS trip were those of Ostrea congesta in small bits of coquina. Fittingly, this outcrop is close to an exit of the Comanche National Grassland, and it's here we end our observations. It's been a great experience for myself and for many members of WIPS who have spent 2 decades with the Cretaceous rocks and fossils of the Comanche National Grassland. I want to thank Bruce Schumacher for the time he spent with us on many visits, teaching all of us about the region, the rocks, and the fossils. His contribution has been invaluable. I also give credit to the following people and organizations for images and photographs. Thank you.
Wow. where do I sign up and when can I do a field trip?
Hang on a
I am
second. I got
serious. I am in distant awe of the Ammonites. Just wow.
I'm a member. Oh, hold on here. I gotta find this thing and there we go. Questions, anybody?
Yeah, where do I sign up and when can I go on a field trip?
Um, the next field trip is going to be one day between December 26th and December 30th. We've had really good weather down there this time of year in December, and fingers crossed for another good one. And that's our next trip down there. I don't know if I'll do a trip down there next year or not, a whips trip. So, but I'll probably be going back down with my drone because there are some things that I still want to record that I haven't flown over and recorded. So, but it's just a beautiful place, and I love it because it's not the mountains.
It's amazing, amazing. The Guarnero shell, there were no fossils found there. And that looked like a very deep layer. Why? What's the theory behind what was going on at that point in time?
I That's a good question. I think it's really preservation bias. Um, a number of significant fossils, but not a lot when it comes to the Graneros, have been collected around Pueblo, 60 miles to the west of the Comanche National Grassland. Um, but there really aren't a lot of fossils that come from the Graneros, period. Just, as I pointed out, you can find fish scales and little bits of fish, tiny bits of fish in the Graneros. Here in Colorado Springs, we can. And same thing. But even the upper unit, I haven't been able to find anything there. I do want to go spend like another weekend or two just concentrating on it because, it's just one of those challenges. All those years you go to Juana Lopez and Bridge Creek and you pick up a ton of stuff, and you go to the Graneros and you're lucky if you leave with a few bits of selenite. Although we do have, like I mentioned, at that one outcrop there in the video, above that there's a prairie with tons of rocks, concretions bearing Ostrea beloidi, and those are indicated in the Cobbin strat column. So. We can get some kind of fossil from down there. They're not very attractive, but they do fill out a collection and they are important.
You had mentioned earlier chalk. Is that the same chalk that is in Kansas that's very fossiliferous?
Yes, it's exactly the same. But out here, again, further to the west of say, Gove County. I spent time in the chalk in Gove County, but most of Kansas, the fossil bearing chalk there is really remarkable. The chalk in this state, the seaway was deeper, so again, I don't know if it's a preservation bias, but there just doesn't seem to be as much. You won't go out and find a big Zephactinus with a gilligus in its belly or plesiosaur. I've picked up little bits of Straya coquina, and that's about it. But then again, it's one of those places that you don't really get a lot, so you don't spend a lot of time looking. But after having been there for a number of years, it's really kind of worth it and fun to consider going down there to spend a day or two just to see if you can coax something out of those more barren formations.
Yeah, I look at some of those outcroppings and I'm like, wow, that would be awesome. But then I look up and go like, whoa, that's going to come down on me.
Yeah. That focus on the Juana Lopez and the Upper Carlisle and the Niobrara, it's those three members that comprise that line of outcrop that I highlighted in Google Earth, that line that runs
Mhm.
diagonally across Otero County. And as I pointed out too, in that one PLSS section, you've got 5 linear miles of outcrop in 1 square mile. And based on the number of places we've visited in 20 years, like I said, I doubt we've covered maybe 5 linear miles of outcrop across the whole area, across the region. And that line is just the rim of the canyon. In some areas, there are canyons incised into those rocks like a little maze. So if you ever get into Google Earth and you look at Otero County, you'll see. And again, those are just places where you walk and the slopes are just covered with fossil-bearing rocks.
Now, the reason that you haven't explored more than that, is it basically just because of accessibility, that you can't get to it?
Well, that's a big part of it. The first few years I went down there, I owned a '98 Nissan Altima, and I could go anywhere that the graded county roads went. But the Forest Service has Forest Service roads, which are little 2-rut tracks, right, for 4x4. So in 2012, I went back down with a Ford F-150 4x4 with a crew cab, and then I started exploring. So yeah, a lot of the really nice places where you've got really good outcrop are fairly remote. And the nice thing is that we've been allowed to camp down there, doing dispersed camping. So you just go out and you find a place you'd like to set up camp, and you do that. And as long as you take good care of the place, nobody cares. And in fact, if you take trash out, the Forest Service will love you. So, but we've got a couple of places that we set up camp, and it's night. It's great dark sky. The nearest highway, US 350, there are places you can get 5 to 7 miles away from that. You can't hear the highway, or in some places you can't see it. Great sky, no city nearby. Town of La Junta is pretty well to the north. So again, and it's also an area that's not popular. It's not, it's not full of tourists, like the mountains. So it's just a beautiful place.
It looks
Road
like,
trip. Let's do a road trip.
yeah.
Well, anyway, yeah, keep an eye on our website. We've got that field trip. That's the Comanche National Grassland trip in December. Like I said, I don't know if I'll do a trip next year or not. I thought about doing a 2-day instructional trip, doing sedimentology and stratigraphy of the Western Interior Seaway, and splitting activities between, as we've done in the past, doing actual stratigraphic measurements and doing measurements, and in other places back off the measurements and go collecting, and then see how things line up. And that's always a useful exercise for people.
See, I want to commend WIPS for the going one step further to expand how we take what we have a passion about, fossils, and bringing it to people that may not be able to have that opportunity. It was really, that is so commendable. And now that it gets harder and harder to find places to collect, being able to look at what's already been collected and to see it, I think that's awesome. And I think that's something we all should do a little bit more of, instead of just collecting for ours. Being able to share it with others.
Yeah.
That's the goal. This is that one that I showed you, that I did the photogrammetry. I'm going to render this twice again as big. The real chore here, I printed this thing out. These things are not solid, but they're filled with infill. So I've got to learn the software. So I'm constantly learning to hollow this thing out and get it so that it prints hollow. So I have to slice the ends off. But what I also learned is, with the printer, printing it oriented this way leaves a texture that's not very pleasant to feel. So what I need to do is print this end this way. So I have to slice the end off, print it that way, slice the other end off, and then I'll take this center part of this baculate and hollow it out and then print it this way. So right now, as it is, I just printed it in two halves.
Mhm.
But I think this will be a fun and worthwhile experience for visually impaired people. And I have got a ton of ammonites to use as references for this project. So
Do you have
not
any?
only stuff that we've collected, but stuff from a few few collections of colleagues as well as a few museums.
Have any
That's
plant
really amazing
materials,
because
leaves?
there's no way we could do you can't do that with, say, the Maison Creek concretions. You can't, those are not tactile enough. You could not explain to somebody a sea anemone or a jellyfish or whatever, so that's really.
Yeah, there's a whole host of challenges. And to be honest, I've been using AI quite a bit. I don't know, that's one of those topics people either love it or hate it, or actually many people just don't know or don't care. But you've got Microsoft Copilot, you've got Google Gemini, Brave AI comes with the Brave browser. All of those are good resources for just tapping, say, that's how I started. So I have an idea for developing an experience for visually impaired people. Is this project even worthwhile? And so, oh yeah, museums are always looking for new content. So then, there's a whole thing I've been researching Braille, for 3D printing. So yeah, there's a lot to it. But it's rewarding, and that's the fun of it.
Yeah, I was wondering if you had any like leaves, that would be in three-dimensional enough to get the texture of it.
I think what you would have to do for something like that is one, to enlarge it, okay, and then the other is to maybe exaggerate the contours of the veins in that wing, to where you could feel it. And then, because this is one of the things I'm thinking of, this is the actual rock specimen here.
Well, there are a lot
And
of
this
the
is
fern leaves that do
yeah.
have the raised texture that I think
So
you
you have
could
this
be able to.
texture, that's right. So what you want to do is you want to be able to get that texture and highlight it somehow so that it can be perceived with the finger. But the whole point being is you start with something, and then my vision, and this is what I need to run past users, you embed something like this into a plaque with Braille and an explanation, and you give them markers that indicate certain things, and then you give them the whole model to actually touch. So
Yeah.
having the smaller one, you can say, okay, here's a concretion. It's a small round rock. It was formed in the goo of whatever organic material was feeding off of, the other organic material. Explain that. And then you say, it's this big. A real one is this big. And now I'm going to give you one
Hmm.
it's this big so you can see what it is. Because, think of the number of times you put a loop up to your eye to see something. You want to take a look at the suture on a baculate. Well, you can't, this is a magnifying glass right here. This is a baculate through the
Yeah, right.
magnifying glass. So that's the perspective that you take.
Now is the club members only that can go on the field trips for instance, or is it is the club a you know an annual fee to belong to the club type stuff, or how does the club work?
Oh, whips.
Right.
Join is $30 for a family, $25 for an individual. Renew year over year. You get the newsletter and you get the invitations to our presentations, and we do meetings 9 months of the year. Actually, the meeting in December is our annual silent auction. It's a fundraiser, and it was really good this year too, by the way. That's where I got this. So yeah, we're all accessible. And then the field trips that come up, they're advertised internally. We don't advertise our field trips publicly.
Right.
But if somebody asks, we'll certainly say, yeah, we're going. So, but yeah, if you're a member, then on the website, you go to the field trips page and you see which one you want, and you can sign up there and pay for your field trip and just register online.
And I live down in Texas, so I'm a little bit, well, I don't know if I'm any closer or not, but than Illinois, but it sounds like I am anyhow.
Yeah, well, coming up, yeah, well, if you come up Texas, you come up through the Panhandle, and then up I-25 at Trinidad, you bear off to the east and drive up to the northeast. So you don't have to come too far into Colorado if you wanted to go.
Yeah. So, and it's a long way across Texas. I'm way down in South Texas along the coast, so
Oh, yeah,
yeah.
that is a long way. Okay.
Yeah.
Any other questions? Any questions about the place or anything?
How many rooms in your house are devoted to all the fossils you've collected?
Actually, believe it or not, I do not have a huge sprawling fossil collection. I collect fossils that are interesting, fossils that have a story to tell, or fossils that that convey something useful and interesting, and then that's it. When I go, I don't collect a lot of stuff, but if I see something that catches my eye that says, "Hey, I can share this with somebody," then that's one that goes in the collection. So,
All right. So this is really rude of me, but one that can share with somebody, raising my hand here.
She
No,
wants
that's
dirt.
awesome. I have no shame. I have no shame. Readily admit it. That was fast, so interesting. I'm gonna watch the video again and again because there's so much information you shared in there that I wanted to sit there and process it more and more because
Yeah.
there's just so many,
Yeah.
the different areas, the different types.
It occurred to me when I finished the product, I finished it too a full. Actually, it was a little more than a week before the conference, and I sent it up to JP, and he asked if I could do identifications on the fossils, and I had just produced this whole thing. I thought, oh my God! So it took 2 days, but I figured out the feature and I developed the rhythm, and I went through and I got it all done. Yeah, it was. I think though that the impression I had by the time I was done that I was able to convey more information in that 30-minute video than I would a PowerPoint, and standing and talking. So yeah, it's a lot of stuff. But for 20 years we did a lot of stuff down there.
Well, it's just the area is so vast, and there's so much. You're showing us so many different areas and how they relate in time and in this one, yeah, that's amazing.
It's the Western Interior Seaway is the whole first cycle is there.
Yeah, I'm still curious though about what were the conditions like while the Granero Shale was beds were being formed. That's where my brain wants to go is what was
Black
it?
shale is like it's an anoxic environment, so not a
Mud and,
real
fine
yeah.
silt.
Yep. Yeah.
But
You
then right
can
on top of that, then you've got, so things changed so much.
oh, you talk about things on top of things. This blows people away. We stand on the prairie and say we're standing at the standing up there by Tempest. We're up near the Smoky Hill Chalk at the very uppermost part near town Tempest. I say if you stand here and you look up, there used to be 3,000 feet of pure shale sediment over where we're standing. Okay. It's all gone. It's down the Arkansas Valley, smeared across the continent and dumped into the Gulf of Mexico. All of those marine deposits that are just gone, gone, gone. So, again, it's one of those things that I try to help people develop an understanding of deep time by saying, how much time does it take to move that much material? Cubic miles, thousands of cubic miles of material of the Western Interior Seaway is gone. So, yeah.
Yeah, and that's what's, and we're seeing it on here and just getting the mind blown, but being out there and seeing it, wow.
So it's fun. Okay.
Steve, one question. I edit the newsletter, or I will have been completed now. Somebody else is going to take it over. But is there a way that you could write a 2-page summary or an abstract or something like that with maybe 5 or 10 slides to summarize this?
Yeah. Yeah. You know what? Let me, how soon do you need it?
Well, one's right now in a couple weeks.
Okay.
But then a month from now or 2 months from now,
I will do that for you, Don. I'll do that for you. I'll give you a kind of a written overview that parallels the presentation, and I can certainly pull images and slides. Actually, what I'll do is I'll just drop frames out of the video for you.
Sure.
So
Awesome.
okay, yeah, for sure, I can do that.
As opposed to sending an email over this video and whatever else, Catherine has your email address, does she not?
Yeah.
Yeah.
I'll drop you a note, or maybe Catherine will drop you a note about it.
Yeah, I'll
Okay.
touch base with Steve after the presentation and everything, and yeah, we'll coordinate it
Sure.
and get it
We'll
to the
close
new
loop on
editor.
that. Yeah, we'll take care of that for you. Absolutely.
Great, thank you.
Yeah.